Today I am going to talk about vector. So the name of the chapter is vector analysis. Now, first of all, a vector is a something which have both direction and magnitude. So, if we draw a vector graphically, then it look like this. Where the length of the straight line is magnitude and the arrow represent the direction of the vector. Now a vector is denoted by the following notation. A vector, and the magnitude of this vector is denoted by modulus of a vector. Now if we change the direction of this a vector, it will be represented graphically by a vector of same magnitude but in opposite direction. And it is represented by the notation minus a vector. Okay, the next topic is vector operation. The first thing that we should discuss is vector addition. Now if we have a vector which is a vector and another vector which is b vector, and if we add both of them, the resultant will be a vector plus v vector. If we represent this diagrammatically, if we represented this by picture, then draw it like this. A vector V vector and the sum will be represented by A vector plus B vector, and the direction will be in this direction. Now this is actually done by vector triangle law. So what is vector triangle law? If we draw a vector like this and start another vector from the head of a vector, then the resultant vector will be A vector plus B vector and in the direction of this. This is vector triangle law. Now let's discuss some properties of vector addition. Let's talk about that. Vector addition is commutative. This means that if we add A vector and B vector, this will be the same as B vector plus A vector. Again, the addition is associative. This means if we add A vector plus B vector and then add C vector, the resultant will be the same as if we add B vector plus C vector and then add the A vector. These two result will be same. Now let's discuss the vector subtraction. to do vector subtraction, we add a vector with its opposite direction. So if we have a vector and b vector, to do a subtraction we will take the opposite of b vector and then add both of them to get the subtracted value. So if we show it by picture, let's say a vector, this will be minus b vector, then this will be a vector minus b vector. The next topic that should be discussed is multiplication of vector. Now first of all, if we multiply by a scalar, if we multiply by scalar, then it will be if we multiply by scalar, the magnitude will be multiplied but the direction will remain the same. Like if we multiply by a scalar a with a vector addition a vector plus b vector, then the result becomes a into a vector plus a into b vector. So it becomes a vector, it becomes 2a vector. The a vector magnitude becomes double in case of 2a vector. Next is dot product of two vectors. Now what is dot product? Dot product is a vector dot b vector and it becomes magnitude of a vector, which is a, magnitude of b vector and the cosine of the angle between them. Magnitude of a vector, magnitude of b vector and the cosine of the angle between them. Now properties is it is commutative. It is commutative. A vector dot b vector is equal to b vector dot a vector, and it is distributive. Distributive means if we multiply a vector with b vector plus c vector, then it will be same as a vector dot b vector plus a vector dot c vector. Next is law of cosines. We have a vector, b vector, the angle between them theta, and the resultant is c vector. Now c vector equal to a vector minus b vector. If we take dot product of this, if we take dot product on both sides, then we get c dot c c square, a dot a square, plus minus b, okay, c dot c c square, a dot a minus b dot a minus a dot b minus b dot b. Now a dot a becomes a square, b dot b, a dot a becomes a square, b dot b becomes b square, okay, minus, now a b dot a and a dot b both are the same as they are commutative. They are commutative, so a dot b equal to b dot a, so it becomes 2ab cos theta. It becomes 2a dot b, and a dot b means ab cos theta. Now next topic, which is cross product of two vectors. Now what is cross product? Now if we take a vector and b vector, and the angle between them is theta. The cross product of them is defined by magnitude of A vector, magnitude of B vector, and the sign of the angle between them, and they have a direction of n cap. Now the n cap is a unit vector which is perpendicular to the plane of A vector and B vector. Now the direction of n cap is denoted by right hand rule. Okay, the cross product has some properties. It is distributive. That means A cross B cross C equal to A cross B plus A cross it means distributive. It means A cross B plus C equal to A cross B plus A cross C. However, it is not commutative. That means B cross A equal to minus of A cross B. The next topic is vector algebra component form. If we take x-axis, y-axis and z-axis, and we can represent any vector A vector in terms of these three, as component on x-axis is Ax, and then the unit vector of x-axis is x cap, plus component on y-axis is Ay, and unit vector on y-axis is y cap, plus component of z-axis is Az, and unit vector on z-axis is z cap. Now to add them, we will add the component in the same direction. If we want to add A vector plus B vector, where if we write the component that Ax x cap, Ay y cap plus Az z cap, and Bx x cap, By y cap plus Bz z cap, then we will get Ax plus Bx x cap plus Ay plus By y cap plus az plus bz z cap. We can only add the component which are in the same direction. And there is another rule that if we multiply by a scalar, that a vector, that becomes multiplied by each component, that ax x cap plus ay y cap plus az z cap. Again, if we take dot product of two vector, then the components there gets multiplied and then gets added. Now then the magnitude of a vector is the magnitude of a vector is root under ax square plus ay square plus az square. For cross product, it becomes determinant form. That means a cross b is written by x cap, y cap, z cap, ax, ay, az, bx, by, bz. That means we write the direction unit vector first, then the component of the first vector, then the component of second vector, and then by calculating this determinant we can find the value of a cross b. Okay, the next topic is triple products. The next topic is triple products. For triple product, first one is scalar triple product. Scalar triple product. Now scalar triple product is shown by this formula: a vector dot b vector cross c vector, and it can also be written as b vector dot c vector cross a vector, and that is also written as c vector dot a vector cross b vector. In the component form, it can be written as ax, ay, az bx by bz cx cy cz. Again it can be written as a dot b cross c equal to a cross b dot c. That means we can exchange the dot and cross. Next topic is vector triple product. Vector triple product is written by the formula a cross b cross c equal to, let's first take the second vector out and give a bracket, then take the third vector out and give a bracket, and then write the dot product of the rest of the vectors. Like we have already written here b vector, then the rest of the vector is a vector and c vector. So the dot product of a vector and c vector, and for this c vector, the dot product of a vector dot b vector. This is also called back cab rule. This is also called back cab rule. The next topic is position, displacement, and separation vector. So the position vector is written by r vector, which means x cap plus y cap plus z cap, right? Again, displacement vector is written as dl vector equal to dx x cap plus dy y cap plus dz z cap. For separation vector, we have to draw a picture that this is r vector, this is r dash vector. Okay, first of all, this is source and this is field, and this is the direction from source to field is denoted by r vector, and this is a origin from which the source and field is measured. So the magnitude of this r vector is denoted by is small r vector minus r dash vector, and this is separation vector. This is separation vector. So the magnitude of this separation vector is denoted by r vector minus r dash vector,